So now that we've gotten that warm up, we're going to start delving into a little bit more complicated questions, starting with as well, what is the electron configuration of oxygen? Okay, so to do electron configuration, it's important to note down our, I guess, shells. So I have the 1s, 2s, 2p, 3s, 3p, 3d. Each of these corresponds to a certain number of elements on the periodic table. So if we wanted to start at the 1s, for example, I'm referring to the hydrogen and helium. So think of it as we're literally counting through the elements in order to be able to get over to where we want to be for oxygen. So hydrogen would be 1s1, okay? The s subshell can only take 2 electrons. So hydrogen would be the first element that has 1 electron, and helium would be 1s2. Okay, so we've crossed over the hydrogen and helium. So we know that now for oxygen, it has at least 1s2. So now let's go down to the next row. Lithium would be the 2s1 because now it's the second row, and then we're still in the s orbital, the s subshell, so it'd be 2s1, and then as well beryllium would be 2s2. Okay, so we've actually now crossed over the lithium beryllium, so we know oxygen at least has 2s2. Okay, and then we enter this side here, columns 13 through 18. Excluding helium, these are your P subshells as I've listed here. And oxygen is the fourth one on this row. So if we count boron, that's 2p1, carbon will be 2p2, nitrogen will be 2p3, and oxygen would be 2p4. This is how you'd find the electron configuration for for oxygen, sorry, because what we've done here is that we've gone through and counted, okay, based on the periodic table, counted and be able to get to this value. The important thing is recognizing which subshell you're in, okay, because as I stated earlier, the S subshell would be the first and second column, okay, that's how we, and including helium, because technically in the S column. And then the second subshell, the P, would be between 13 and 18, those columns, not including helium. And then as you see here, I also have like a 3D, for example. Your D subshells are actually the transition metals, typically between columns 3 and 12. And then there's also another subshell, but we don't really need to discuss that right now. The important thing is knowing how to count through, because you're literally going to be, if you're ever unsure, just count through each element, notice which notice which element number whatever you're trying to find is, and make sure that these values here should add up theoretically to your element number. Oxygen is the 8th element, and as you can see, if I added the 2, 2, and 4, I can say that yes, this represents oxygen because of the fact that I have 8 in total here. So that will be the electron configuration for oxygen, okay? So, with that being said, as we're reading through, they also mentioned noble gas notation. For this, we don't really need to do that. The noble gas notation, though, is simply, to save you some time, because sometimes you get really far, like selenium or bromine. You get further and further in the periodic table. The noble gas notation is where you take your most recent noble gas. In this case for oxygen, it will be helium, and then you continue from the next row. So then I'm starting now with 2s2 2p4. This is a noble gas notation because this is pretty much saying that it has everything that helium has, and now we're focusing on what it should have theoretically on its valence electron, like this outer shell. You notice that we could have picked anything, like if we're doing like selenium, which is on row 4, for example, you would notice that we would use argon to say represent that, oh yeah, it has everything, you know, before it has everything that makes argon, and then you'd be adding the parts that come after it. So you'd be like 4s2 and so on. So with that being said though, let's see. Oxygen, exactly. Chemical elements with atomic number of 8, 1s2, 2s2, 2p4. Perfect. As you can see, here is their noble gas notation as well. It's He2s2, 2p4. So with that, let's move on to question